let's see. So we're basically going to be talking about how to find factors and zeros in all polynomials. I've got two theorems here that we're going to write down, and we'll talk about one at first, and then we'll talk about the other one later today. Okay, so two theorems here. The second one, this is the one we're going to use first. If a polynomial can be factored, and x minus c, some number c, is a factor, that means when you plug in z or c, we're going to get 0. So that's basically saying if x minus c is a factor, then c is a 0. That's the same thing as saying if x minus 4 is a factor, then 4 is a 0. Right there. When we plug it in, we get 0. But it has this extra part here that I think is helpful. When we divide using long division or synthetic division, then we're going to get a remainder of 0. Now that actually ties into the first theorem, which we'll talk about later, but basically if you divide by x minus c, whatever you get as the remainder is what you would get if you plug in c to the function. So if you get a remainder of 17 when you divide by x minus 5, it means if you plug in 5, you'll get 17. We'll look at that one later. So we're going to remind ourselves how we do long division and synthetic division. You do need to know both of these. Synthetic division is not a shortcut that we can always do. Sometimes we have to do long division, and we'll remind ourselves of what the conditions are to be able to use synthetic division. So let's talk about long division first. We'll do a simple one to start. So if I write it like this, 2x squared minus 3x minus 5 divided by x plus 1. The way that we want to set that up is like this. Make sure that you don't write a square root symbol like I almost did. We get so used to writing the square root because we actually end up writing that more often, but the long division symbol just, is a straight line right there. So the way that we divide is we just look at the leading terms. So we ask ourselves, how many times can x go into 2x squared? Or if we did 2x squared divided by x, what would we be left with? 2x. So we put that up there. Then we need to multiply and make sure we're distributing when we do that. So 2x gets multiplied by x and 1. So we get 2x squared plus 2x. And when we do that, the leading terms should match. So I should have 2x squared here and 2x squared here. That's where we came up with this, would be so that this would match up here. Then our next step is to subtract. Now, some teachers describe this as multiplying by -1 and adding them together. Is that the same as subtracting? Let's say I have 5 and 3. 5 minus 3 is 2. Or if I multiply 3 by -1 and add them together, is that the same as subtracting?
Yeah.
Yes. So whichever method feels better for you. What we are doing is subtracting. So if it feels better to distribute the negative and add the two together, do that. If not, just remember it's subtraction. So totally up to you. 2x squared minus 2x squared is 0. The first thing there should always be 0 because the leading terms match. 3x minus 2x is -5x. After that, we're going to bring down the next term, which is the -5. And then we repeat until we can't repeat anymore. So, same thing. Look at the leading terms. What's -5x divided by x? Or how many times does x go into -5x? Yeah, so -5. Then we're going to multiply that. We get -5x minus 5. We subtract. This is something minus itself. -5x minus 5 minus itself. So that's going to be 0. So getting a remainder 0 means that x plus 1 is a factor. And x equals -1 is a 0. Oops. And like we could have factored this one without using long division, right? We know how to factor the original problem, but it's just to show the process here. And our answer is this part right here. Since there's no remainder, it's just this top part. That's the answer. We would say that's the quotient. This is the only problem with long division is sometimes it goes down the page pretty far, especially the longer the original problem is. So I'll scroll back down here. But that is the process. Okay, so have you guys start this one, and then we will go over it together. All right, you guys, let's check this here. So sometimes with long division, especially if it's something longer that we're dividing, it's very easy to make mistakes. It's very easy to know how to do long division and actually be good at it, but then you just mess up a negative sign when you're subtracting, or mess something up when you're multiplying. So as long as, the key is basically as long as you understand the process and you can repeat it. If you get the wrong answer, I would say it's not the end of the world if it's like a little tiny arithmetic mistake. That happens all the time with long division, even for me. So as long as you're getting the process, then you can feel good about where you're at, and just practice it a couple times and make sure you got it. If you're not understanding the process, that's when we need to make sure we're asking questions of like, okay, wait, what is the order of things that we do, etc. Because after this, we'll move on to synthetic division, but we'll have some time later to practice. So first, again, we divide 3x to the fourth by x squared, or we think about what would we multiply this by to equal that, or we think about how many times does x squared go into 3x to the fourth. It's all the same thing, so just whatever feels easiest. So what do we get when we divide them?
3x squared.
3x squared. So that 3x squared goes up top. Next, we're going to take 3x squared and we multiply it to all three of these. 3x to the fourth plus 6x cubed minus 3x squared. And then we're going to subtract. When we subtract, what we should notice is they should be lined up like with the like terms above each other. So the x cubed should be over top of each other. The x squared should be over top of each other. That should always happen. The only time it might not happen is if there's a term missing from either the dividend, like there's no x cubed term, so we have to put a plus 0 x cubed in there. Or if there's something missing from the divisor, like if it's just x squared minus 1, we have to put in the plus 0x. So you guys might remember that from last year. But other than that, they should automatically line up. So when we subtract, we get 0. Negative 2 minus 6 is negative 8x cubed. 4 minus negative 3 is adding 3, so that's plus 7x squared. If it's helpful, often what I'll do is I'll write it over here like negative 2 minus 6, oh, that's negative 8. 4 minus negative 3, oh, that's 4 plus 3, that's 7. So sometimes I do that. We bring down the next term. That's the 5x. And then we repeat the process with x squared and negative 8x cubed. So that's going to be negative 8x. We multiply negative 8x to all three of those. Negative 8x cubed minus 16x plus 8x. Same thing, we're going to subtract. The first one's always 0, so I often just don't write 0 to keep it less crowded. Long division is already pretty crowded, right? So I usually don't write the 0. So we have 7 minus negative 16 x squared. Sorry, x squared right there. 7 plus 16 is 23 x squared. And we have 5 minus 8, which is minus 3x. We bring down the negative 3. And here I'm just going to probably zoom out so we can fit it all on one page here. And do the same process. So we have a plus 23. We multiply the 23. 23x squared plus 46x. Where'd it go? Minus 23. We subtract, we get negative 49x. So, especially the last one there, I would do something like negative 3 minus negative 23. Oh, that's negative 3 plus 23. That's going to give me a plus 20 right there. So again, if you messed up along the way with the negative sign, that's okay. That's easy to do. Like even right now, I'm double checking my answer key just to make sure I'm doing it right, because in the moment, it's easy to mess up negative signs. If you're messing up because you're adding and not subtracting, it means you're confusing this with synthetic division. So make sure that you're subtracting. The way we present our answer is it's the quotient plus, always do plus, and then you do the remainder over the divisor. So this is the divisor. This is the quotient. Anybody remember what this is called? The dividend. Nice. So this would be our answer. Questions on the process? Okay. And you guys get plenty of practice with that on the delta math, and we'll have some time in class today to work on the delta math. Just basically, this is stuff that you just need to practice so that you get good at it. Okay, let's do synthetic division. So there's a time when we can use synthetic division, and there's a time when we can't. Turn to your neighbor, ask them, do you remember when we can use synthetic division and when we can't?
Oh my god, I forgot.
Does anyone remember? Yeah.
Is it when there's only like two terms, like x minus 1, x plus 2, x plus 3, and not, you can't do like x squared or like extra stuff and x?
Yes, that is correct. So not just two terms, because like x squared minus 1 is two terms, but yes, what you said was exactly correct. So the way we describe that is we can only use when dividing by linear factors. That means they have a degree of 1. So, and exactly what Anna said, we can't use it with x squared, x cubed, x to the 4th. If we could use synthetic division all the time, we would use it all the time. Long division would be obsolete. We wouldn't be teaching it anymore because it is a long process, but unfortunately, we cannot. We need to know both. So with synthetic division, basically everything is the reverse of long division. Everything's upside down, everything's reversed. I don't know why, I don't know who came up with that, but even the division sign is reversed. So we do a little upside down division sign. Across the top here, we put the coefficients of the dividend. We're going to divide by the 0, not the factor. So if x minus 2 is the factor, or might be the factor, what would the 0 be?
Positive 2.
Positive 2. We bring down the leading coefficient. That's our first step. And then comes the part that we're about to repeat. So I like to put a little line there, because we're not going to repeat that every time. And we're just going to multiply and add, and that's what we're repeating. So what we're multiplying is the root, or the 0. I'll call it the 0. I'll call it the root. And the number on the bottom. So it's 2 times 1. We put that result here. We add those two numbers together. That result goes there. And then we run it back. 2 times -1 is -2. Then we add. Then we multiply, then we add, until we run out of numbers. This is the remainder. And our result is the new coefficients. And we need to decrease the degree by 1. So if we divided x cubed by x, we're going to be left with x squared. So it becomes x squared minus 1x minus 1. And then same deal for our answer. Always add, plus -6 over x minus 2. No.
If we're always adding and the remainder is a negative, couldn't we like technically swap the positive for a negative?
Yes,
Okay.
you could. If you always add, it's always right.
Right.
Especially with long division, I see folks mess up a lot when they do a negative sign. Like actually, I just gave a quiz in AB Calc the other day, and where they had to do long division, and a whole bunch of folks messed up the remainder because they tried to change it to a minus sign, but they didn't do it the right way. So what they did was they had a question like this, and they wrote 3x squared minus 8x plus 23 minus 49x plus 20 over x squared plus 2x plus 1 minus 1, sorry. And this is wrong. Turn to your neighbor, why is this wrong? Why is this wrong? Yeah.
Because you're like subtracting the entire remainder instead of like you're like subtracting out the remainder instead of adding.
Okay. Okay. You actually are allowed to subtract it because the 49x is negative, so we should be subtracting the 49x. What should we be doing with the 20?
Subtracting that as
Well, based on our first remainder that we got, we're actually adding the 20, right? Our remainder was negative 49x plus 20. So we have a negative 49 and a positive 20. If I put my negative sign out in front of the fraction, we're actually subtracting both because I would have to distribute. And so that's why this is wrong. This is a different remainder. So if you're going to put a subtraction sign out front, you would need to basically factor it out of the whole top. This is why I say always add it, because then you don't have to worry about this. Just always do plus. But yes, you could do it, but especially if it's two things, you have to make sure you're subtracting the entire thing. So that's why I say always add. Just keeps it simpler. Okay, questions on the synthetic division process? A lot easier, right? That's why it exists, because it's easier. Okay, I'm gonna give you guys an example to do. Divide these two. Remember, as we do this, we want -6 to be on the outside there. Take 30 more seconds. So again, we want -6 here because we're dividing by the 0, or the potential 0. Bring down the first number, multiply, add, multiply, add, multiply, add. We get our remainder of 0. So this becomes 2x to what power?
Squared.
Squared. Yeah. Minus x minus 1. There's no remainder, so we just write our answer like that. Okay, let's do another one. If you have questions on the first one, let me know as I'm walking around. Okay, so this is how we want to set this one up. Because we are missing the x squared term. So we need to make sure we have a 0 up there for the coefficients. So take 30 more seconds. All right. So this should be our result here. Any questions? Coming back to us? Feeling good? All right. We're going to do just a couple different types of problems that we're going to see with this. Whoa. Okay, so some of you guys are doing it already, which is great. What would be the first method that we would use to find the remainder?
Synthetic division.
Synthetic division, exactly. Okay, so let's do that. Okay. So, did you guys get -6 as your remainder? Me too. The other method, this is going to be that first theorem that we saw. The remainder, when we divide by x minus c, is the same thing as plugging in c to the function. So, in our example here, if we're dividing by x minus 2, it's the same thing as plugging 2 in. We're going to get the same result. So, not -2, but it's x minus 2, so we use +2. So 2 cubed minus 3 times 2 squared plus 2 minus 4. And plugging 2 for x, we're plugging in just to the top right there. Okay, did you guys also get -6 for that? Well, which was faster, synthetic division or plugging in 2 for x?
Synthetic.
I found synthetic division to be faster. So actually, the reason that we care about this theorem is because it's usually faster to do synthetic division to plug in a number instead of actually plugging in the number. We could just do synthetic division and it ends up being way faster. So that's kind of interesting. In the grand scheme of things, though, I would say this theorem is less important. So we're going to move on. And we're going to do some more important examples. This is a problem you're going to see way more of. So we want to factor f of x completely, but we know that x plus 2 is a factor. So what would be our first step?
Synthetic division.
Synthetic division, exactly. When we do synthetic division with -2, what should we get as our remainder? Before we do it, what should we get as our remainder if this is a factor?
0.
Yeah, we should get 0. We must get 0 because we're told that this is a factor. Okay, do that. Then whatever you get as a result, you're going to factor that too. So when we do our synthetic division, again, we should get 0 as our remainder. If we don't, it just means we multiplied or added wrong or maybe forgot a negative sign somewhere in there. But if I say using the given factor, we know that the remainder is going to be 0. So what we're left with here is x squared minus 4x plus 3. And how does that factor? Okay, so let me show you guys a couple different potential almost right answers, but still not quite right. If I just say this is my answer, that's not right. What am I missing?
X plus 2.
Yeah. Okay, so x plus 2 times x minus 3, x minus 1. Don't forget the one that we were given. And actually, I am still missing something.
F of x equals?
Yes. So we need to make sure it's labeled. We need to present our answer. So don't forget f of x or the given factor. Okay, we've got one more example that we're going to do. Bless you. All right, give this one a try. So which one of these ended up being a factor? X plus 2. So if I tried 5 first, here's what it would look like. 2 times negative 10, negative 11, 55, 50. Okay, well, I can tell that's not going to be 0 as a remainder, whatever it is, you know, so obviously not 0. You might be able to figure that out partway through. You get to this negative 11 and you start to multiply, you're like, wait a minute, this is not going to work out. You could just stop early. That's fine. So when we do it with 2, it should work. Great, it works. So this means we have 2x squared plus 3x plus 1. Does that factor? Yes, it does. What does that factor into? Yeah.
2x plus 1, x plus 1.
Nice. Okay, is that the answer? No, what am I missing?
X minus 2.
Yeah. Okay. There we go. Okay. So this is part 1 of our factoring in zeros. Next class, we're going to look again at the rational root theorem, which is when you have to make that P and Q list of like all the possible factors. We're also going to look at some situations where we have imaginary roots and how that plays into all of this. So that's next class. That's part 2. This is part 1.